Hey everybody, Sean Tierney here from theautomationblog.com, and in this episode of the Automation Podcast, we sit down with Yen Lee from IFM Effector to get up to speed on IOLink. Yen, I want to thank you for taking the time out of your day with your colleagues to give us this presentation about IOLink. I'm really looking forward to using the samples you guys have sent in to the Automation blog, and I'm looking forward to this presentation as well. So thank you for putting this together.
You're welcome. Today I'm going to talk about the IOLink technology. But before we get into all the nitty-gritties there, I want to introduce myself. Yen Lee. I'm the product manager for IFM for our network and controls products. I've been with IFM for almost 20 years now, and of those 20 years, I've been dealing with network and control systems, primarily with integration into various PLCs and fieldbus protocols. Okay. And again, before I get into a lot of the details and the exciting technology of IOLink, for the audience who are not familiar with IFM, I want to give you guys a little bit of brief overview of the company itself. Okay, so who is IFM? IFM is a global company. We're privately owned. That's the nice thing about it. We're on a second generation of the Mahlhofer and Buch family. Because we're privately owned, one of our biggest things in the market, a unique part of our sales, is that we're a direct sales. I would approximately say that 90% of our sales is direct, with certain areas that are about 10% with distribution that maybe they don't have a lot of industries there. We like the direct sales model only because we feel that we want to be close to our customers and that you get the best experience when you're dealing directly with the factory in many cases. So as you can see in the map, we have 70 plus different units worldwide. Most of our manufacturing locations are in Germany, but we do have manufacturing locations in the US, Poland, Romania, and Singapore. Our current sales right now are over 1.1 billion annually. And one of the biggest things that we're doing in the US is that we want to be able to be like the Amazon of the industrial world, right? One of the metrics is here that we have is when we get an order, we want to be able to ship this order within 24 hours. And that's one of the metrics that we provide as a company, again, to provide our customers with the best experience when you're dealing with IFM. And then with IFM, we offer quite a lot of different products. Right? And you see in this map here, we have various different technologies that we've employed. Many of these are homegrown within IFM. And because we have such a diverse technology portfolio, we're able to offer really a full system solution ecosystem to many of our customers and vendors here. And because of that, we can also develop new technologies and new systems solutions based off of what we currently have. And we back up a lot of our quality with the 5-year warranty on all of our products. And that's a unique part of what IFM does for the market here. So let's get into the discussion that we have for today. So what is IOLink, right? And I'm probably one of the biggest proponents of the IOLink technology. And the first question, and whether you're familiar with the IOLink technology or you kind of know a little bit about it, I think today's session is going to go over the 30,000 feet view of IOLink and kind of give you a good feel of what this technology can bring to the table for you if you give it a little bit of a chance here. So the first question usually that comes with that is what is IOLink, right? And there's a couple things when you mention IOLink, there's a couple things we need to demystify, with that term. Typically, when I mention IOLink, people think it's another fieldbus protocol, something that's similar to Ethernet IP, Profinet, EtherCAT, Modbus, you name it. But IOLink is absolutely not another fieldbus. It's actually developed to be just a point-to-point communication protocol. And what I mean by that is it's really a sensor communication protocol. What you need is something we call an IOLink master, and we'll explain this a little bit more later on in this presentation here. But an IOLink master really doesn't look anything different than your standard field mountable IO in the field. it will just have a flavor for IOLink. And again, we'll get into that in a little more detail here. Then you have the ability to connect this to an IOLink sensor. And an IOLink sensor is something you might or might not already have already. But this is all connected with your standard cabling. And the point here is that it is just a point-to-point communication. It's not meant to replace your existing field bus. It's meant to complement that. What we're going to be able to do and what I'm going to be able to show you is that now we're able to now fully utilize the bandwidth that's available on the field bus side, because now we can get more information from your eyes and ears on a plant.
Yeah, and I want to ask you a question here, and I think you just alluded to it. Can IOLink sensors be used as standard sensors? I mean, like a photo eye or a proximity sensor, or do they all have the ability to act like as a dumb sensor as well as an IOLink sensor?
Absolutely. So one of the points that we'll go through later on is that in lots of cases, many of our customers or many of the people out in the market today might even actually have an IOLink sensor already, but they're just using in the digital IO form of it. And if they just knew what they needed to unlock the data from sensors, it's really literally just plugging into one of these masters, and you have the ability to be able to access so much more information. But not everyone knows that, right? So yes, to answer your question directly, the sensor can be used as a standard thumb on-off sensor, or it can be simply, turned on to be an IOLink sensor. And we'll explain what that really means later on. So like I said before, you really need only two components to really get the IOLink technology up and running versus the IOLink master and an IOLink device. In this case, I'm showing just an IOLink pressure sensor. What's also unique with the IOLink technology is that you don't need any specialized cabling. As you can see here, your connection from the IOLink sensor to the IOLink master is just using a standard 3-wire sensor cable. Okay, and that's the typical cable that you're using in any of your installations today. That doesn't change. So the nice thing about this technology, your current wiring and your current hardware, for the most part, will stay the same. So the next question usually is, okay, so now that you see how the connection works, we realize that this is a point-to-point communication protocol. What kind of information are you actually able to get that's different? So with an IOLink sensor, we are sending a digital value back to the PLC via the IOLink master. And this true digital process value is a really interesting and quite lower cost alternative to an analog signal. And what I mean by that is, from the PLC point of view, you're no longer receiving a 4 to 20 milliamp signal or an on-off signal from it. What you're actually going to get is the actual true scaled value of the sensor itself. Okay, and I'll show you in the next PowerPoint what that truly means. In addition, because it's a digital signal, a digital signal is more immune to EMC. That typically can affect an analog circuitry, right? So if you have EMC on a digital signal, you're less likely to have, let's say, noise issues on that. And if you do have some kind of issue on that, the signal would drop. With an analog signal, that's a little different because analog signal doesn't have any true high and low limits per se. So if the signal is affected by EMC, it could affect the analog signal by a couple milliamps here and there. But in a process, that could be critical, and you don't want that, and you might not know that that's being affected. That's the reason why, in this case, a robust digital signal is much better than an analog conversion there. So the other thing is with the digital value, you get a much more accurate signal back at the PLC. And that's the reason for that is because we're eliminating many of the ADD conversions here. So let's take a look at it a little more closely.
I'm going to just interrupt for a second. This is like, it just opens your eyes. It's like, I actually can get a better signal with this digital connection than just a standard analog connection. I mean, it really makes you start thinking of like, hey, it may actually make more sense to deploy my analog devices as IOLink than
Yeah,
my
and
4 to 20, which I've been using for decades.
yeah, and the big nice thing about this, Sean, too, is why don't we use more analog signals on our processes? The big thing usually is, well, there's a pretty significant cost adder when you're adding analog back in to a system. So in many cases, because that cost adder just is too much, we default back to, all right, I'll just take an on-off signal because it's the cheapest way, and I'll work my machine and process to it. But imagine being now to be able to get more granular information from your sensor into the PLC and potentially not have that cost adder. And now, what can you really do with your machine? What kind of new insights can you actually really bring even more so? And that's just getting a more, let's say, granular signal back to your controller. So let's take a little closer at that, at the last statement I gave here about more accurate signal by eliminating ADD conversions here. And let's take a look at that in more detail and reasons why that's the case. Like I said, one of the best use cases for IOLink is the ability to be able to replace anything that's analog with a digital communication path. So when we take a look at a conventional analog wiring and analog signal, in this case, I'm taking the example that I showed you before, a pressure sensor, and we're going to send this via traditional analog wiring back to the PLC. And you can see here in this diagram that there are multiple ADD conversions that's needed in order to get back to the PLC. First, you have an ADD conversion that converts the analog sensing element into a digital signal into the microprocessor of our sensor. From the microprocessor, now we have to reconvert that to an analog signal to bring it out to the real world. And now you have the analog signal transmitting over those 2 wires or 3 wires, typically, back to the PLC, which then again needs to convert the analog signal back to a digital signal to be processed in its microprocessor. And through that whole entire life cycle, you might lose a little bit of accuracy here because of all those ADD conversions. In this case, we're showing, maybe you might lose 0.2 bars from that. Okay. So the true accuracy is not simply just from the sensor's specification. It's really something you need to look at from the whole life cycle of the transmission itself. Now, when we take the same situation, but then we're using IOLink, now you can see here we do only one ADD conversion. We have to do one ADD conversion from the sensing element side of the sensor. But from there, everything else is transferred over digitally to the microprocessor. So we're eliminating, at least 2 ADD conversions within the cycle, and because of that, we're able to give a much more accurate signal at the end of the transmission. The other aspect of IOLink is that, we're getting this digital value, this digital process value, which is a very great thing that we're seeing here. But because IOLink doesn't just, let's say, convert things to digitally, it also opens up the communication path between the sensor and the control system now that never existed before, right? So now that we're able to open this up, a lot of sensors in the market are pretty smart. For the most part, they're driven by these little microprocessors that are in them, and they have firmware running on them, and there's tons of data that you can access on them. The problem is, I would say a few years ago, you didn't really have a chance to be able to access that data because the controls architecture of the world didn't allow for that, or there wasn't a way out of the sensor to do that. But now that with IOLink, we have the ability to really access all the different parameters, all the different information that microprocessor and bring it to the controls world. And with that, we're able to also add in a lot of, let's say, data memory, data diagnostics that we have access to the sensor. Here, I'm looking at it from a diagnostic data point of view. Your control system now has the ability to be able to know if the sensor is actually on or off, right? you'll have the ability to be able to see what type of sensors on it. Is this a pressure sensor? Is there a serial number associated with it? You can track it if you wanted to, if there's any changes with it. You can see if the value of the digital signal is valid. Right? Is it within the normal measuring range or not? Right? How many hours of operation you're using with this specific sensor? And there's many also specific diagnostic data that's dependent on the type of sensor you're using. In this case, this pressure sensor example I'm showing you has an overload pressure counter. So you're allowing the sensor now to kind of take a look and tell you, okay, how many times has this sensor gone above and beyond the limit that I think this process can be. So you're taking away the need for the controller to do the work and allowing the device that's closest, the most accurate, to kind of do the work and give you the information itself. And this list is just a partial list of what you can actually access with an IOLink sensor. There's many more and many more other use cases with it. But the big thing is that the IOLink really opens up the bandwidth, the information path for these sensors. So IOLink is an open standard. It's not just an IFM only protocol or communication. It's actually supported by many different companies. And that's one of the reasons why this technology has grown so rapidly and is being adopted so quickly, because the community is very large. It's got over 300 members and it's increasing every day. Most of the PLC manufacturers are part of this consortium, part of this community. Most of the sensor manufacturers are part of this community. And because of that support, the adaptation of this technology is fast and quick because the ecosystem is growing and people are seeing the support. It's not just a technology that is brought in today and gone tomorrow. In my opinion, because of all the different advantages that you're going to be able to see here, it's going to be the de facto standard in terms of sensor communications moving forward, in my mind. And of course, for more information, you can always go to the IOLink community link that's listed on this PowerPoint here. And that brings up a good point in terms of why I think the technology is being rapidly adopted, right? So, this is kind of a full view in terms of what your controls architecture would look like. And if you look at this slide here, and if you're pretty familiar with field I/O and just plugging your sensors in, there's really not a lot of changes to your controls architecture. So the IOLink technology lends itself to kind of blend into what you're doing today. You're still going to use your existing field bus architecture that you're using today. Nothing changes by adding IOLink to that. If you're used to using field-mounted I/O blocks, again, an IOLink master in this case won't change that. It's going to be very similar. You will set it up in the same way as any field bus I/O that you would put on any bus system. The only difference is that you're going to get a lot more data to work with, and that's okay. You can use all that data, or you could decide not to use all that data. It's a very scalable system based on your needs and based on what you want, what you think is valuable information to you. But it's there if you want to. And then the ecosystem is growing at such a tremendous rate. You can see in this, you can connect almost anything to IOLink today. IFM has a very large portfolio of different devices, of IOLink devices, one of the largest in the market. And we have different solutions there for that. So I think the key for this technology is that we're able to provide a lot of this without changing what you're doing today. And at least from the IFM point of view, we're also not increasing the cost of such a unit. And we'll get into that a little bit more, why I'm saying we're not increasing costs there. The next thing I wanted to address is, what is specifically the type of data that you can get, okay? So to address that a little bit, let's take a look at what a traditional sensor looks like today. So in this example, I'm going to put one of our flow meters out there. right? So, and of course, I'm assuming everyone knows what a flow meter is. It's really there to monitor typically to monitor the flow rate of any liquid type of fluid. So we take this sensor today, and let's say I apply it to traditional controls architecture. This is the typical wiring here, right? You have two outputs that are available to the controls world for you to get information on it. And for this specific sensor, these two outputs, we have the ability to be able to select, what those outputs can be. It can be for, to let you know that there's an empty pipe in the system. We can take analog outputs here to give you the flow rate, the temperature. We can give a pulse output for a totalizer. We can reset any of the counters here, right? So a lot of things you can do with the sensor because it's a pretty intelligent device. But I think you can kind of see the problem here now, right? We only have two outputs here. So we can't really fully utilize all the different advantages of this device. So if I want to use all of these, I can't. I will have to now pick and choose which one is my highest priority to be able to put on my outputs. Okay, so it's a compromise, and unfortunately, that's not something you always want to do. And then the other aspect is, okay, well, why don't we just add an 8-pin connector to it instead of just a 4-pin? Then if we do that, then we can get all these signals. Wouldn't that be great? Yes, definitely you can do that. But then that comes with a certain disadvantage too, because now that means more connections. That means more wires, more input cards, more labor for that. And that all equates to more cost. And I think that's the main reason why, ideally, yeah, we want to be able to use that, but maybe we'll just make some of those compromises and stay with something more standard here, right? But, what if we could do all this? What if I could give you all this information? What if I can do all this and still keep with the same standard 4-pin connectors you're using? Not having you change any wiring at all. I mean, that sounds great. And that's where IOLink comes in. So if we take the same flow meter and simply just use the IOLink portion of it, we can now get the true digital measurement values, right? And we typically refer to this in the IOLink world as the cyclic data, because this is the type of information that you need to continuously get in the controller, because this is the information you need to control your machine and processes. In this case, we're going to give you the actual flow rate value, the temperature value, the actual totalizer count, the device status information here. And these are all coming back to the PLC as the actual value and not a 40 to 20 milliamp signal of any form. And you're able to get all this at the same time. Okay. In addition to that, you also have another segment of data set that you can get. And we consider these, let's say, the internal data memory of the sensor. And this is what we also refer to in IOLink as acyclic data. And I usually call this on-demand data, because this is not information that you typically need to, let's say, control the machine continuously, but maybe there's an event, maybe there's some information you want at certain times of the processes, but you don't need it all the time at the PLC, because you don't want to, again, the PLC also has a certain amount of information that it wants to take. You don't want to give it too much information. You only want to give it information when it's needed, and you don't want to overload it. In this case here, we can send, let's say, the maximum, high and low temperature flow that the unit's seen. We don't need to have the PLC have that logic. You can just simply pull this information directly from the sensor. We can tell you, what is the last totalizer count from the last reset. We can give you serial number revision verifications. We can put this the sensor into a simulate mode and put parameters in there, because sometimes you don't have flow going through the sensor during commissioning, but you still want to make sure that the data and everything goes back to your PLC and your logic is correct, so you can put it into simulation mode. We have now the ability to be able to access every parameter that's available on this flow meter if we want to make recipe changes or change parameters on the fly depending on the process and and material flowing through there. So again, there's a lot of information that's available, and this is just some of the ones I wanted to point out that I think are useful. But if you look at the sensor's information, there's a lot more data that's available there. And this is specific, and this can be specific for every type of IOLink sensor in the market. And then we also have another subsegment, which we call events data. And this is really just related to even more specific diagnostic data for the sensor. So we would be able to get this back into the PLC with some kind of error code or diagnostic data that we could bring in and monitor back into the PLC here. And these are 3 different things and data sets that we can get from an IOLink device. And this all comes in, again, I can't stress this point enough, it all comes with all this data comes in a standard 3-wire cord set. And from our point of view, this IOLink enabled flow meter compared to a standard IOLink flow meter is the same cost. There's no added extra charges. Or we're not saying, hey, because you're getting more information from this, we can charge more for it. You're getting all this information for the price point of a digital output device.
I was going to ask that because I remember back in the day when DeviceNet was first becoming pretty popular with Rockwell. It just seemed like, a photo eye, maybe it was $50, but if you wanted the device, then it was like a $35 adder because they had to put the CAN chip in it and the packaging and whatnot. If we look at the IFM line today, do any of the products have an adder to get the IOLink?
None whatsoever. And in fact, we've been using IOLink in our manufacturing processes for years. That's kind of how we're able to clone and parameterize our sensors to a factory setting. And we've already built in let's say the IOLink chipsets within this, which are relatively inexpensive anyway, into the unit. So that's why when the introduction of IOLink came out, there was really no cost adder from our side of everything. It was something available for you. You just simply needed to want to use it. So the next slide here, well, it just gives you a little bit more of a visual in terms of the type of data that you see. This is actually an HMI screen that I created a few years ago just to show what you can get from an IOLink sensor by default without having to do much work to it. You can see here, you get the device identification, so you can validate whether a sensor is the correct sensor that you've placed on it. Because unfortunately in this world, many of the sensors kind of look alike, but they might have different ranges, and you might accidentally put a sensor like that on that might not be correct. But now with IOLink, you can validate that and make sure that the end user has placed the correct sensor back on to the correct location there. You see here the big thing is this pressure value. So of course this example is a pressure sensor that's I think is rated from 0 to 30 bars. Like I said, again, you're getting the true digital process value of the sensor. So instead of receiving a forward 20 milliamp signal, so back in the PLC you see that as maybe a 4,000 to a 20,000 value. Then you have to then scale it and do the math to make sure it relates to some kind of bar or PSI rating. You don't have to do any of that with IOLink. You're going to actually get the actual right measure of value. In this case, on this HMI, I'm showing it's 12.7 bars. That's actually what you're going to see in the PLC. And then you have a host of diagnostic information and flags that you're able to pull. And that's all part of the standard IO table when you're looking at IOLink. Like I said, again, the only major difference when you're employing IOLink is that you just have a larger data array to work with for each device. And you can choose to use as much of that or ignore as much of that as you want. So the next question is always a big question as well is, okay, it sounds great. We've established the hardware to integrate the technology sounds great. This data is really useful for me. The question always goes back into, okay, how do we integrate this into our controls? how hard is it? Is it going to be something that I can do quickly, or is this going to be some kind of a huge learning curve, right? And I'll always be honest, with any new technology, you're always going to have a learning curve, no matter what, no matter how simple it is. There's always going to be some kind of small learning curve here. And with IOLink, I truly believe that learning curve will fall on the small side. And many of the vendors like ourselves and others in the market, we try to provide the most seamless, transparent way of being able to bring data into your controller's architecture by providing function blocks or AOIs that allow you to essentially plug and play and get your data right away. So in this case, I'm showing you two function blocks that that IFM has developed for the Allen Bradley systems and Siemens systems. And what they essentially do is you drag and drop these into your block, into your logic, plug in your sensor, fill in a couple parameters, and for example, the Allen Bradley AOI, you essentially give the AOI a name. You tell it which input data array to use, and that's usually just the input data array of the IOLink master block you're trying to use. And then what port number is this sensor connected to it? You fill in those three parameters, we give you the rest of the data here. And we provide you the vendor ID, device ID, the pressure value, and all the diagnostic information. By just inputting three parameters in, you have the data to work with. And now as a PLC programmer, you can go through your day because now you know where the data is. Now you can do your real work, right? And now the learning curve is a little quicker, and we're able to get people up and running very quickly here.
All right, so these are great. I can't wait to try both of these, but where do I go to get them?
So, from the IFM website, you can go into our resources tab, and under resources tab, you can go to the download area. And what we've done is, like, I know it's sometimes tough to navigate manufacturers' website because information's all over the place here, right? Or it can be. I can't speak for everyone else. So what we've done is we've created an area where what we call startup packages. And these startup packages include all these AOIs, all the documentation that steps you through the whole process from start to beginning of each of the different PLC integrations in terms of how to use it, how to integrate everything. And we call these startup packages. And we have it for various PLC platforms that we've had experience integrating and documenting and everything like that. Again, our whole goal is not to bring technology in and make it more difficult. We want to bring technology in and make it as simple as possible for you to use. Once you figure out how to use it, then you can look in some of the details when you have time to look into it, instead of being crunched into trying to implement new technology and being under the gun to try to get it up and running.
Excellent. I can't wait to try it out.
Yeah. So this next graph here is just to show that, how does IOLink compare to, sensor communication protocols that are available today, right? You have, of course, what most people use are just on-off the information. You have analog if you want to control your processes more granularly, and there are even some devices on the market that are Ethernet based. In the end, what I want to show is that IOLink is it's giving you the best of both worlds, right? IOLink is giving you all the different advantages that you have with Ethernet based devices, but at the cost point of an on-off device. And that's really where the IOLink is really shines here, because it's giving you all those advantages of Ethernet devices without its complexity and taking up multiple, let's say, IP addresses, like giving you all this at the price point on off. I get a lot of questions when I talk about IOLink is, why the quick adoption of this technology, right? And you can see since this product launched around like 2013, there's been exponential growth in terms of IOLink. And as more and more people are using it and more people are getting on the bandwagon, they're starting to realize all the different potentials of what you can do here. And the question is, why is that, right? Why this technology? Why is this technology growing? While other technologies have maybe failed or stood still over the course of its introduction. And what I believe is that IOLink, I think, reduces a lot of the barriers often associated with new technology introductions, right? And these barriers are typically these three big C items that I typically correlate. The first thing with any new technology is complexity. How complex is this for me to bring in, right? And typically when we think new technology, like I mentioned before, there's a learning curve. I got to do something different from what I'm doing today. It's just going to add more trouble, and I have to justify this time here. Well, IOLink, and I think as I showed you, really minimizes the learning curve, right? Again, you're not changing a lot of the controls architecture that you have in place right now, right? We're actually just adding more data for you to work with. And with the AOIs and the function blocks that exist for many of the IOLink sensors in the market today, you can make the integration into your existing architecture pretty quick, right? All we need to do is point our customers to where the data is. Once we tell them what the data is, most people know how to use this technology. And it's also scalable. Like I said, again, you can still use IOLink data as simple as an on-off switch, or you can use it as much as you see fit. These are all important things to make sure that the technology is not complex here. The next thing is cost. Okay. Usually, again, when you introduce new technologies, the first thing comes into mind is there's probably going to be cost, because this new technology is going to do something more. It's going to give me more information. Well, that more information, of course, is going to say, hey, there's going to be more cost involved for me, right? And that's not the case with IOLink. There is a very minimal impact on the actual cost of your system. Again, as I showed you here, from the IFM point of view, the sensor doesn't cost anymore. It's the same sensor cost, whether it's IOLink or a digital on-off sensor for us. Our IO blocks for the IOLink masters are also at a very aggressive cost point for that as well, because we truly believe we want to bring technology in so people use it, and we want to eliminate cost as a factor there. Okay, and when you're really looking at IOLink to potentially replace, let's say, analog cards, you're almost looking at a 50% savings there. So when you're comparing the IOLink in terms of what you can do with analog, conversion, there's a lot of cost savings there by itself with this. Okay, not only does it not increase cost, in some cases it reduces cost. The last thing is change, right? So again, with any introduction of new technology, what do I have to do with what I'm doing today to accommodate this new technology? And one of the big things, and one of the reasons why IOLink was created, one of the standards and requirements, was that IOLink doesn't change what you're doing today. Like we stated again, IOLink uses the same standard cabling for your sensor connection. None of that changes. Your connection to your PLC, that doesn't have to change, because you're using the existing fieldbus architectures there, right? The only thing that would be different in your controls architecture is swapping out the actual IO block with an IO block that is IOLink compatible, and we call that the IOLink master. But it's really, at the end of the day, no different from an Ethernet block that's really on the market. Again, it just gives you the ability to give you more data. Again, because today the IOLink ecosystem is very large. There's so much you can do. There's so many devices out in the market because all the different vendor support. I like to say, you can connect IOLink the way you want, right? So regardless of your application, it doesn't fit for IOLink in all the different processes and applications out in the market. This example is just showing you if you're using field-mounted IO or industrial machinery, yeah, you can connect it. And there's a whole entire ecosystem that can support all the different devices that you need to attach to it. And this is just a few of them. And these are the few that IFM specifically offers. But again, the market's very large out there, and there's many other devices out there in the market that you can use that you can also attach to really any of these IOLink masters. You can take a look also at the food and process hygienic world. There's also a solution for connecting IOLink there, because there are IOLink masters or Ethernet blocks that are IP69K rated, and then you have a whole entire ecosystem and devices that are suited for that environment. So again, we can also apply IOLink in this area, which is probably one of the biggest benefits for this industry, because in this industry, there's a lot of instrumentation that uses 4 to 20 milliamps signals here. And we can absolutely replace many of those 4 to 20 milliamps with IOLink intelligence on here.
Quick question. I mean, I think everybody's very familiar with all the sensors, and IP69K is huge in food, right?
Mhm.
And beverage, wash down conditions. Can you talk a little bit about the analog hub? I am not familiar with your analog hub
Yeah.
product.
Yeah. So obviously, entering this market, there's a lot of different sensors in the market, and there's a good chance that we're not going to be able to cover and convert all the instruments in these processes over to IOLink directly. And that's slowly changing very quickly. You can see with the product portfolio. But the analog hub is kind of a way for us to bring legacy 4 to 20 milliamp signals back over to IOLink. So you don't have to take one or two analog devices back to the PLC directly. You can still keep it within this architecture by collecting all these 40 to 20 milliamp signal, because that's a nice thing, right? So although IOLink is used primarily for sensor intelligence communication, but because we have a larger bandwidth of data being transmitted, we can take the analog values, collect them in this hub, and then bring them back. In this case, we can bring back 8 4 to 20 milliamp, 0 to 10 volt signals back to the PLC with just one device. So that is, at least from my point of view, a very cost-effective way of bringing analog back. And then we also have situations where IOLink is not being used for controlling a machine. You might be able to use it for data collection. Okay, we didn't really go over this in this presentation. Maybe we'll do this in another discussion here. But we do have the ability with these IOLink masters to be able to talk to other systems, other cloud systems, SCADA systems directly, bypassing the PLC. And by doing that, we can employ other solutions like real-time maintenance, vibration, track and trace solution, energy optimization solution, and combine that with IOLink and bring that data to these database systems and stuff, And that's really the big reason here why we think that IOLink is a foundational piece for the IIoT concept, right? Because the entire IoT concept is trying to get more data. So if your eyes and ears of a plant can only give you on and off information, you're going to get very limited insights, and you're not going to really be able to achieve this whole entire IIoT concept. But with IOLink, we now have the ability to get a lot more information from your eyes and ears. And to me, that's the foundational piece in order to do the other things we want to do here in the future. And I think that's also another reason why the growth of this technology is exponentially growing is because of that. We now have a cost-effective way of being able to give you more data.
I don't want to get in a segue on this. So I'd love to have you come back and just talk about this, Yen. But I did want to ask, a question, that blue line. Are we talking that these master blocks support, is it MQTT?
That's correct. So these blocks here, and that's a good segue. We can segue into the anatomy of let's say a typical IOLink master from us.
Okay.
So in this here, we have a version of these IOLink masters that offer an IoT port. And this IoT port is a separate Ethernet IP address that allows us to connect to really any cloud-based systems. SCADA systems are probably one of the big things too. And we can communicate all this information via MQTT is one protocol. We can also do HTTPS on it. And these protocols are all based on the JSON language there. So it makes it, let's say, more human readable when we access this data. And we can do this concurrently with both the controls portion running and also this IIoT port running. We call it the Y path is our internal term, but really we're sending data in two different locations concurrently.
Nice. I mean, I think this is so important because, and I try to stress to everybody I talk to that you really do not want to take your field bus, your Ethernet field bus, and connect it to the internet. That's a recipe for disaster. And by having a separate IoT port, you're not giving them access to your controller. You're not giving them access to your process system. That IoT port, let me ask you this. Is that IoT port unidirectional?
It can be bidirectional, but you can actually lock it to be read only, or you can have read-write access as well.
Okay. So you could stop somebody from the outside from changing, the parameters on your flow meter or whatever.
Absolutely.
You could lock it down. And by coming in that port is not jumpering over to the field bus, correct?
No,
that is dedicated.
Yes, it's dedicated. It's two different microprocessors. We have one microprocessor just dedicated for the IoT port connection, and then we have another microprocessor for the field bus. So they're two separate entities.
Wow, that is amazing. I did not realize that some of your masters had this feature. That's pretty awesome.
Yep. So yeah, it's kind of a forward-thinking way of what we're looking at, because we, like you said, we realize that as the industry requires more data, you're probably not going to want to route all this information to the PLC. Right? The PLC just wants to control your machine. It doesn't want to collect data, because that also puts a lot of burden on the PLC programmer, because the PLC programmer just wants to get the machine up and running. And there's a little amount of processes and resources there for it. So why do that? Why put the burden on there where you don't have to? The concept here is, send information to the PLC for what it needs. And this other larger information, let's send it directly to the data sources itself, bypassing the middle person in this case. Going back into the IOLink master here, so we talked about a little bit about the IoT port. As you see here, the anatomy is again, it's very similar to any Ethernet field mountable device. You have a power connection here, you have Ethernet connection, and kind of back to your point earlier, each of these I/O ports here are configurable. So the I/O block can bring in a digital input signal to it, or you can send a digital output signal to control an LED light or a low wattage solenoid, of course. And then the information here is that these are all configurable, and these are different. You have 4 different ways you can configure each of these pins, essentially. So there's flexibility there, right? Just because you buy an IOLink master doesn't mean you can't take in and use standard signals into it. Again, that's because of the way we designed the specification for IOLink, because we wanted to be backwards compatible here. Okay, and this is just one of the different variations of masters that we offer, and you'll see there's many different variations in the market as well. And this is just give you, I'm not going to go into specifics here, but this just gives you an overview of all the different types of versions on here that we offer. And we have versions that allow us to have higher amperage outputs, because there are applications such as hydraulic valves that you need to be able to control. There are versions that don't have this IIoT port. We have versions that can be mounted into the IP20 cabinet. But the best thing about it is they all integrate into PLC the same way. It's just slightly different hardware flavors of it.
If I remember correctly, when you purchase this, you have to know your field bus, right? There's not like a select a switch on it. If you want Profinet, you have to buy the Profinet one, etc.
Correct.
Mm-hmm. Okay, good.
And last but not least, the last thing I wanted to address is that, IOLink is a growing technology. And that technology is not simply just going to stop with what I'm showing you today. Within the community, there are many ways that we're looking to expand and continue investment into IOLink. You will see, IOLink specification. There's actually already an IOLink specification available for safety. So again, you'll see that come into the market, soon as well, where we can integrate safety sensors onto the IOLink protocol. We can bring wireless into it, because that's another technology that seems to be growing and have a lot of buzz of being able to have wireless communication between devices. And as the community grows, we're standardizing more on how to make sure that each devices from one vendor or another are somewhat interchangeable with it as well. And that's where the smart sensor profiles comes in. So all these things, and this is just one snapshot. There are probably many different other working groups within the community that are working on all kinds of different aspects of the IOLink expansion here. And these are just some of the three that are probably one of the more major ones that I'm seeing in the market today. That concludes this presentation. Hopefully you've learned a little bit about IOLink and you get excited about it. So I will hopefully, Sean, talk to you another time, and maybe we can go over some other topics that might be interesting for your audience.
Yeah, I want to thank you again so much for putting this together. IOLink it's open, right? So anybody could kind of sit down and talk to you about IOLink, but I really appreciate, because I not only learned, got a review for me, but for some of the viewers and listeners that may be brand new to them. But I love that we also could learn about the features in the IFM product line, because you do have such a great product line. And I'm really looking forward to testing out the samples you have here on the show and sharing it with the audience on setting them up and using them. And I just really appreciate it, because, man, and especially with that dedicated IoT port, that's just awesome. I think, and on the fact that even your masters can be used as just regular digital inputs as well as IOLink inputs. It's just a lot of good information. I know the audience is going to appreciate it as well. So thank you again for taking the time, and the team for taking the time out today to put this together for us.
No, I appreciate it, and thank you very much, Sean, for this opportunity. And again, we can work with you and explore anything you want to explore within our ecosystem.
Awesome. Thank you.
I really enjoyed that presentation. I hope you did too. I want to thank Yen for taking the time out of his busy day to put that together for us. And I really appreciate them sending in samples. I can't wait to get them on the Automation Show and try them out. But with that said, if you enjoyed his presentation, please give us a thumbs up and a sub. And if you want to support our work and get some free rewards, you can do so over at patreon.com/automation. And don't forget, I spend my days over at theautomationschool.com teaching automation courses. So if you know anybody who needs to get up to speed on PLCs, HMIs, and SCADA, please send them over. With that, I just want to wish you all a very safe, healthy, and happy week. And until next time, my friends, peace.